Hi, my name is Philippe. I'm the AI project manager at Wikimedia Deutschland. And yes, I will be presenting the Wikidata MCP, or Model Context Protocol, which is basically a new way to connect AI clients to Wikidata's data. So Model Context Protocol, just a quick introduction. It's basically a standardized way to provide AI clients with tools. Basically functionalities that you define yourself that provides the AI model access to external resources, APIs, files, databases, or any type of functionality that you develop. So for example, here we have a really simple MCP of a weather MCP. It takes in a location and the date from the AI and provides it with temperature. So then the AI model can make use of that information and respond to the user accordingly. So since MCPs are standardized, they're really easy to set up with any AI client that supports basically tool calling or MCPs. So in the case of the Wikidata MCP, it provides access to Wikidata's to the Wikidata API directly, to the Sparkle query service, and to the Wikidata vector database. So I wanted to do like a quick introduction to the Wikidata vector database to understand the relevance of it in the MCP. So the vector database, part of the Wikidata embedding project, basically provides AI models access to Wikidata's data. And it does so by improving accessibility of Wikidata by enabling semantic search. And it encourages the open source AI community to build projects with Wikidata. So we're all familiar with the knowledge graph behind Wikidata. It's structured, it has explicit connections of the data, whereas the vector database is unstructured and have disconnected data. In this case, the knowledge graph is used for explanations for precise retrieval of information, whereas the vector database is more used for exploration for similarity search or semantic search. Knowledge graphs have human-defined relationships in the data, whereas vector databases have machine-learned mapping of the information. So what does machine learned mapping means? To understand this, I wanted to go through how we set up the vector database. So we take each item from Wikidata. For example, here we have orange, the fruit. We pass it to a large language model, which will then transform it into a vector, which we can then consider as like a mapping or coordinate of this information into our vector database. And the coordinate basically takes into consideration the context or the meaning behind the item. So after transforming all of our data on Wikidata into vectors and adding them to the vector database, we can see that our data creates clusters based on the context or the meaning. So orange, the fruit, gets clustered with other fruits, whereas orange, the color, even though they have the same label, it's far away from that cluster, clustered with other colors. So after creating the vector database, we can then perform semantic search. And the way it works, we take basically a query from the user, either a question or a statement in natural language. We also pass that to the large language model, which will then map it to our vector database. And after mapping it, we look into the surrounding items that are from Wikidata and return them to the user as a result of the semantic search. And basically those items capture the context or meaning similarly to the query. So they can either answer the question or lead the user to somewhere on Wikidata that might answer the question for further research. So to understand better vector search, I wanted to compare it with keyword search and Sparkle, which we're familiar with. So keyword search and Sparkle are both very precise because they do exactly what we expect. Whereas vector search can be a bit loosey, it might provide you with items that are not as relevant to what you're looking for. However, with this loosiness comes a wider scope of vector search, because in that case, it can be used for discovery, for exploration, for maybe finding items that are relevant to your research, but you might have not thought of while you're doing your research. Whereas keyword search has a narrow scope because it's only used to find items that you already know of, that you're trying to look for. Sparkle has a wider scope because of all the functionalities that it can provide. In terms of ambiguity, vector search can handle ambiguity because it takes into consideration the context of what you're looking for. Whereas keyword search struggles with ambiguity because it may find you items that have similar labels, for example, but completely different meaning. With Sparkle, you can handle ambiguity by adding more filters to the query. The one thing that Sparkle struggles with is its syntax, its user-friendliness. It's hard to write, and you need to understand not only the syntax, but also how Wikidata connects together in a certain domain, and all of the identifiers that you need to be able to write a proper Sparkle query. In comparison, you have vector search and keyword search. They're user-friendly because they have natural language interfaces. So this is where the Wikidata MCP comes in. It combines the discovery, the exploration aspects of vector search with the precision of Sparkle. So these are the tools that are currently supported in the MCP. We have item search, which combines keyword search with vector search and returns Wikidata items. So for example, here, if we search for Nobel Prize in Physics, keyword search gives you exactly the item you're looking for, whereas vector search, in this case, it provides you Nobel Prize in Physics and also examples of physicists who have won the Nobel Prize. So for example, Neville Francis Mott. We have property search, which is the same exact thing as item search, but returns to you Wikidata properties. So if you search for a word received, keyword search gives you exactly that. And vector search on top of that gives you also example of properties that might be similar to a word received. So nominated for and winner. There's get entity claims, which takes in an item from Wikidata. So for example, here we have Neville Francis Mott, and returns to you all of the statements that are connected to this item. So in this case, we get a sex or gender, place of birth, and we can see also here award received, Nobel Prize in Physics. We get claim values, which is basically like an extension of get entity claims. But in this case, it gives you, on top of that, deprecated values, which are not included in get entity claims, as well as references. So it takes in an item and a property. So Neville Francis Mott and award received. We can see here that we have the same exact statement that we saw earlier, but included a reference. So here it's connected to the official Nobel Prize website. And finally, we have execute Sparkle, which takes in a generated Sparkle and executes it and returns either the results or an error message if that occurs. So we saw that the MCP is standardized and it's very easy to set up. This is like a quick example using Claude, how we can set it up. As you can see, it's super easy. You just go to connectors and settings, you add a connector, and make sure to add this URL right here and /MCP for a remote MCP server URL. So after you add that, you can simply enable the MCP in the chat, and then Claude can make use of the tools that we provided earlier whenever it sees fit. You may also have noticed that the Wikidata MCP has read-only access. And this is for multiple reasons. One being to avoid spamming of unverified information. Another is to avoid bias injection and loss of diversity, and to avoid model collapse. Model collapse is basically what happens when we train AI models with generated content, and if we do so recursively. And if we do that, basically we get model collapse, which where the model generates unuseful information or data that is distorted, basically. So here I included visualization of model collapse, and I did it with image generation because it's just easier to see. And we can see at the end it generates the same image with like distortions and not very useful. And this is because regardless of how complex the AI model is, there's always an amount of error between the training data and the generated content. So if we keep on training with the generated content, the errors keep on accumulating and accumulating until the AI model becomes completely useless. And in this example right here, we can also see how we lose diversity with generated content. We can see the difference in diversity between the training data and even the first generation, not only the other ones. Because also, regardless of how complex the AI model is, at the end of the day, there is some type of averaging of the information that is found in the training data. So this averaging, while we're doing this averaging, we lose some information that is not as popular or popularly found in the training data. So if you want to make use of the MCP, I suggest you prompt the LLM to follow a particular workflow to make sure that it generates proper Sparkle queries. So I personally start off with a discovery step where it uses the search tools, vector search, keyword search on items and properties to find items and properties that are useful to generating the query. And then after that, I use an exploration step where it uses the get entity claims and get claim values to find in a certain domain how items are connected together in Wikidata. And after doing so, after gathering all the information and making sure all the information that we need, we have them, then we can generate a Sparkle query. We can test it out and then verify if the results are satisfactory, if they make sense. If they are, then we're done. If we're not, then we keep on repeating all of these steps until we find a Sparkle query that is satisfactory. So I wanted to share like a quick example of what it will look like when we make use of the MCP. So here I asked Claude to write a Sparkle query for Wikidata to find all planets that have more than 2 moons. And this is without the MCP. I noticed that it used instance of planet, and it used the correct QIDs. And but for example, here instance of planet, it used a direct connection rather than looking at the hierarchical topology, so it wasn't enough. Also, it used Earth's moon to classify moons, where this is not fully accurate because this QID is only for Earth's moon and not all moons. However, when we used the MCP, I prompted Claude with the same prompt, but also included the workflow that I explained earlier. We can see that it followed these steps. There are more steps in there that it included, and it tested out multiple Sparkle queries, but just for visualization purposes, I just included the steps that are relevant. So it first searched for planet with the vector search, and it found Earth and Jupiter as examples. Then it used keyword search with natural satellite to find this QID. It got the entity claims of Earth and found that it's an instance of planet and has a child astronomical body moon. It did the same thing with Jupiter and found a child astronomical body of Io, and then got the statements of Io basically and found that it's instance of a planetary moon. So it made use of planetary moon instead of moon to classify moons, and it used planet to classify planets, and it also added the hierarchical instance of and subclass of statement right here to make sure that it's not just the direct connections. I believe it tested 2 Sparkle queries, and that was the last one which it found that it was satisfactory and gave good results. So some use cases of the MCP. We have Sparkle generation, which we just saw an example of. There's question answering, which is kind of like the same exact thing, but providing the user with answers instead of Sparkle queries. We have cross-database integration, because we all know that Wikidata is connected to a lot of external databases. So it could be considered as like a hub connecting all this information into one. We have fact-checking, particularly when using the references that are found on Wikidata. And finally, we have a continuous research conversation, allowing the user to do follow-up questions and ongoing exploration as it's making use of the MCP. So if you want to learn more about the MCP, you can scan this QR code right here. And if you want to try it out, you can find more information on how to connect it in this project page. And you can make use of this URL right here. And if you have any suggestions on what to include in terms of tools or any additional updates that we can add, feel free to add them in the discussion page. Thank you so much.
Wow. Thank you, Philippe, for the wonderful project and update to everyone. Yes, very impressive. Quote from Friedrich that this is a very impressive project. Now let's open the session to our participants here. If they have any questions or comments, please feel free to raise your hands. And I see there's 2 hands that's raised. Let me just scroll and find Elan HR. Okay, Elan HR, can you please unmute yourself?
Yes. Hi. Very interesting presentation. I'm curious. How are you evaluating the items embeddings? And I guess a follow up is, how do you see this being used for fact checking rather than just item or property retrieval?
Yeah, good question. For evaluation, basically the vector database completely different project as for semantic search on Wikidata. And we wanted to make it more of general purpose rather than like a specific use case. And that's why for evaluation, we gathered some different data sets that are found online. One interesting one is called Mintaka, which is basically question answering pair, and all of them are connected to Wikidata. So basically we created the vector database, and then we queried the vector database with these questions and checked that the responses from the vector database are similar to the correct responses that are in the data set. That's one quick example. And there are examples with named entity recognition, for example, and another one that I forgot, but different use cases other than just question answering. And you had another follow-up question. Can you repeat that?
Oh, yeah. So I was curious how you envision the item embeddings being used for fact checking.
Yeah. Okay. Yeah. So I'm currently actually testing that out. So I don't have like a full on, yes, this is how it works. But currently what I'm doing is I'm using the vector search to find items that are, like, given a claim, I search the vector database to find items that are relevant. I search for properties that are relevant, use those two lists to then find statements that are relevant. And then this wouldn't be enough because this is like the results wouldn't be, it's a little bit loosey, so it's not very correct with the vector search. So then I would need another step, which uses an NLI model, which is like a fact-checking LLM that takes in the claim, takes in the statement from Wikidata, and just tells me if the claim aligns with the statement on Wikidata, if it contradicts it, or if it's not relevant at all. So, so this is something I'm currently trying and checking if it's accurate or not.
Thank you, Philippe. Daniel has also raised his hands. Daniel?
Yes.
Yes.
Yes, thank you very much. It was an excellent presentation. I was very much looking forward to it. And on Friday, I was presenting a use case where I would like to use this tooling. We are building big Wikibase suite instances, which are kind of staging areas for Wikidata, where either we are not sure of a named entity resolution, disambiguation, or we have pictures that we want to send to commons, but we need to figure out the rights clearance and these kind of things. And we would like to use vectorization, and I'm wondering that the tooling that you are mentioning here, if I'm not mistaken, DataStax. So would it be easy and possible to replicate this in a Wikibase suite that is very similarly set up to Wikidata with like themes and everything? So how do you see that, the replicability of this in a Wikibase suite?
So for the upcoming year, we do have a plan to develop extensions of the MCP itself to Wikibase instances. But our current plans rely on just keyword search for the MCP rather than the vector search. So hopefully that works out and you can make use of that. In terms of the vector database itself, we don't have currently an extension to like a one-click create the vector database. We hope that our next plans include like some type of documentation or an extension where you can create that yourself. But it should be possible with if you want to make use of like open source technologies, you should like it's very possible to switch to vector databases that are infrastructures that are open source and available. Yeah, currently with the code that I have, it needs a little bit of tweaking to be able to make that switch, but hopefully in the future we make it easier to create that.
Thank you, Philippe. We have questions in the chat. Let me just read out from Chris Baum. Ask, have you compared the results to spinach?
Yeah, that's very interesting. I am currently like testing out the difference between spinach and what I can do with I mean, currently I'm using Claude. Of course, it makes a huge difference at what AI client you're using. What I like about this is that you can, like the follow-up is way easier. You can correct the AI model and then like you can kind of together create a proper Sparkle query. And in terms of this, you have a bit more control of like the functionalities that you include. For example, one thing that like every AI client struggled with is normalized quantities. So that's something that I'm including in the generate Sparkle description to help the AI model know how to filter on quantities, for example, by normalizing them. And I noticed that spinach is struggling with that, for example. Yeah, I'm not sure what other example I can give, but yeah, that's basically what I'm thinking about.
Thank you, Philippe. We have also another question in the chat by F News. So I'm asking, does the MCP code support other wiki bases?
Yeah, that's what I just shared. That in the next year or so, we hope to create extensions for that.
That's so wonderful. We have also a comment by Alex saying that, by the way, the GitHub Grok desktop is also a Git client that can also use MCP. And Lucas asked a question, what is the license of the MCP code? I don't see a license file at, the GitHub link.
Yeah, there's no, maybe I didn't add a license. You can find it on the project page, I believe, if that's the correct one. But it's open source. You can feel free to make use of it. I'll just add the license after this.
Thank you. Just let me jump straight to a question by John Samuel. It's a related question to F. Nielsen, asking, is it easy to build MCP for Wikibases using the code for Wikidata?
That I will have to explore in the next year. I'm not sure yet because I've been working closely with Wikidata and not Wikibase instances. So yeah, I wouldn't know how to answer this.
Thank you. And Ellen HR also asked, what also are the latest embeddings available for download somewhere?
We're working on that as well. We want to make it possible to download all the embeddings that we created. It's gonna take a little bit of time because of all the upload speed of because it's around I believe it could be around 700 to 1 terabyte gigabyte 700 gigabytes to 1 terabyte. And also we're looking into what that means legally in terms of EU standards with publishing generated content.
Oh, I think that's all we have the questions, and there's a lot of comments which we will put into the Etherpad. So, there's one last question just nice from Ian asking, is there a QR tool for the Wikimedia colors like the one on screen?
I don't know which online tool that I use, but yeah, there are QR code generators that you can add colors to them. So yeah.
Thank you, Philippe. Thank you, everyone, for the wonderful questions and very engaging. Also, a big thank you to Philippe for working on this project. For those who do not know, actually, Philippe has been working on this most of the time alone by himself. So it's really a great effort and an amazing effort as well. So thank you, Philippe.